Okay, so this is for 5.3 and 5.4. And this is all the circumcenter, in-center, centroid, and orthocenter. Okay, like I said, hopefully you read on your sheet, and the very end of your sheet tells you which things go with which, okay? That Pomasico chart comes in very handy in terms of studying for what you're doing. Tell me what a point of concurrency is. It's where all of your lines intersect. So for us, we're going to say it's the point where 3 or more lines intersect. Okay, so that is a point of concurrency. You are dealing with a lot of points of concurrency in this chapter, okay, or these two sections. So the first one we're going to talk about a little bit in more depth on this first example here is we are going to find the circumcenter. Okay, so they will give you a graph. Where's my nice graph? Sorry, I gotta use an ugly. Oh, just kidding. So they'll give you a point at 0, 0, a point at 4, 0, a point at 0, 6. Okay, so that you have this triangle. Okay. If we're finding the circumcenter, what 3 lines are we drawing? Look on your sheet. What kind of bisector? This is the perpendicular bisectors. Okay, so if you're looking at something like this, and I want the perpendicular bisectors, if I find 2 of the perpendicular bisectors, they're going to meet somewhere. Do I need to find the third one then? No, because wherever the first 2 meet, the third one will meet there also if it's done correctly, okay? So which 2 of these 3 lines, line 1, line 2, and line 3, which 2 are the easiest to find a perpendicular bisector of right now? 1 and 2, it's the horizontal and the vertical, right? So if I'm going to find the perpendicular bisector of that horizontal line, I can see right now this is 1, 2, 3, 4 units long. So if I bisect that, how many units is it? 2. So I'm going to go 2 units over, and then I need to go perpendicular. Well, right now it's horizontal. What's perpendicular to horizontal? Vertical. So we're going to draw a vertical line like this. So that would be our perpendicular bisector, okay? Same thing from line 1 here. That is 1, 2, 3, 4, 5, 6 units long. Cut it in half, that's 3 units. 1, 2, 3, put a point there. And it's vertical, so I wanna go horizontal. Okay, so my answer is the point where those 2 things meet. What point is that? 2, 3. Okay, so that will be my circumcenter. 2, 3 is my circumcenter. Are you with me right now? Don't do constructions right now. You're going to be really lost when you get to the bookwork. Okay, so that's one thing that you're going to do. We're going to jump over so we get that stuff out of the way. Another way that you will see it asked to find the circumcenter is they will just give you the points. Now, if you want to graph it, you can graph it and find it that way. But if you don't want to graph it, there's a really nice little shortcut that you can do. Okay, let's say they give me these 3 points. If I don't feel like graphing it, as long as these 3 numbers are really only 2 different numbers, and then these three numbers are really only two different numbers, what I can do is I can just find the average of those two numbers, and that's going to give me that midpoint and the midpoint, right? It's like we're doing the midpoint formula here. That will help me find what my circumcenter is from these 3 points. So yes, you could graph it every single time. And if you want to graph it, go right ahead. If you want to attempt a bit of a shortcut, you're just going to do midpoint formula with both of these. So midpoint formula for my x's would be 0 plus 3 divided by 2. Do you remember midpoint formula? Is that coming back a little bit? So what would you do on the right side? 0 plus 2 divided by 2 for this set of numbers, okay? Remember, that only works if you have two numbers that are different. If they're all three different, you can't do the midpoint formula, okay? Then just graph it, and you'll have to do a little more graphing work there. So if this is your setup, 0 plus 3 divided by 2, 3 over 2 is 1.5. Don't put a parenthesis there. 2 divided by 2 is 1. So this would be my answer. That is my circumcenter of the triangle that is formed with 0, 0, 3, 0, and 3, 2. Questions on that? Okay. So that's kind of what you'll see in the 5-3 stuff. That is not what you've already done construction-wise. The 5-4 information, you're going to start with centroid stuff. So they're going to tell you D is a centroid. DE is 6. Find BE. Okay, oh, sorry, this would be example 3. So if I give you this triangle, do you remember from your paper, when you find the centroid, what did you get? 3 whats? 3 medians gets you the centroid, okay? So if I draw a triangle, I'm gonna try to make some straight lines here. Remember, a median is just the midpoint of a side connected to the opposite side. So they're going to give you everything I'm giving you right now, okay? This is just what will be given to you already. But they'll give you a midpoint here and say those two are congruent. Therefore, this line here is a median. Okay, so there's one median. Another median would be cut the next segment in half. This is not going to be drawn perfectly, but we'll use our imagination a little bit. Okay, so the green would also be a median. And then your last one, see how well we did, would mean that these are congruent and this is your midpoint. Okay, so this point right here where they all meet up, that's D. Okay, that is our centroid right there. The really cool thing about a centroid is it is the center of gravity for a triangle. So if I were to cut out a triangle, and I should have done this, shoot, I forgot to do this ahead of time. Take a piece of cardstock, cut out a triangle, find the median. You should be able to, on the tip of a pencil, the smallest little pinpoint, you should be able to set your triangle on it, and it will balance perfectly if you actually found the median, the centroid with the medians, because it's the center of gravity for a triangle, okay? But here's what it also does, which is pretty cool. You have your triangle, your medians, broken into pieces. So if I'm just looking at the green right now, my centroid, my point of concurrency, breaks my green line into 1/3 of the line and 2/3 of the line. Okay, and that will be for all of them. So the black one, this would be 1/3 of the line. This would be 2/3 of the line. How can you tell which one is 1/3 and which one's 2/3? 2/3 is bigger than 1/3, right? So the smaller one is 1/3, the bigger one is 2/3. The one that comes off the vertex is always the 2/3. So that means on my red one, this is 2/3 of the line, and this is 1/3 of the line. Okay? So we know that about it. They won't tell you 2/3 and 1/3. I'm just showing you that that's how it works. We're going to take all that away so we can see what this problem has. So in this problem, if this is A, B, C, and we're going to call this E. Okay? They told us that DE is 6. So this length right here is 6. What fraction of the whole line is that? It's 1/3, okay? So think of that as a sentence, as an equation. We're saying DE is 1/3. Oops, my E didn't go. DE is 1/3 of what segment? BE. Okay, well, we know the length of DE. DE is 6, so 6 equals 1/3 of BE. So you're just gonna multiply by 3, and that means that BE is 18, right? If BE is 18, then how long is BD? 12, okay? Here's the beauty of this. These lines always work out so that one is half of the other, but the whole thing is, if you break it into thirds, you would get the whole thing. So for instance, if I told you the longer piece here, CD, was 8, what would this segment be? That would be half of it, 4. Okay? So if I tell you the shorter piece, you double it to get the longer piece. If I tell you the longer piece, you cut it in half to get the shorter piece. But what if I tell you the whole thing? So if I tell you AX is, let's see what number is going to make sense here. Let's say 21. Okay? If I'm telling you this AX has a length of 21, that is 3/3, right? It's the whole thing. What's 1/3 of that? Just divide by 3. So you're going to cut it in 2/3. That would make this piece 7, and the other piece what? 14. Okay, so if you get a piece of it, you're either doubling or cutting in half. If you get the whole thing, divide by 3, because it's 1/3 of it. Okay? Questions on that? Okay. Last thing, I'm going to draw you a picture. You don't have to try to draw this with me right now. If you really want to, go right ahead, but it's going to have a lot of things going on. But I just want to see if you know what everything is now. I'm going to try and draw this as true to scale as I can. That's not. That one's not great. Okay, looking at this picture, can you tell me what the purple line is? Look at your markings that are in purple. What is the purple line of the 4 things? What? A what? It's not a median. Notice what it is. Purple markings show that they're congruent, and it's 90 degrees. It's a perpendicular bisector, okay? So this one is a perpendicular bisector. Okay. Pick another color. Can you tell me what one of the other ones is? What's orange? Orange is an angle bisector. Right, because you had these markings showing that the angles are congruent. What's green? Green is not an angle bisector because that was orange. Notice where green lands. Same point that the perpendicular bisector did, right? So these are congruent. But it goes to the vertex. What's that? That's a median. You gotta get real familiar with all these different names. So that one's a median. What's the last one then? What's this one? It's an altitude. If it's perpendicular and goes through the vertex, that's an altitude. Okay, so you should be able to see a picture and say, those are altitudes, or those are medians, or those are perpendicular bisectors, or those are angle bisectors based on the markings that they give you. Okay? Any questions on that? Okay. You have about 10 minutes.